lecture. It's completely up to you. Okay? I always say stick around, and because there might be something that you won't, you may not have caught yesterday. Um, so that's what I would do. So yesterday we did the note sheet, and let me just highlight some stuff. So this was all about graphing quadratic functions. And of course, quadratic functions are the parabolas that I'm talking about. And most of you are familiar with the standard form y equals ax squared plus bx plus c. Okay. And then back last week when we did the absolute value vertex form, we had the equation up here. I wrote it up on top. The y equals a times the absolute value, x minus h plus k, where hk was a vertex. We have the same form for parabolas. And that is a times the quantity x minus h squared plus k. And this form, the vertex form of a quadratic function, okay, it's different than the vertex form of the absolute value function, is the easiest one to graph. In fact, it's so easy that it's easier to do this by hand or manually than with the calculator. And I think yesterday I showed you the calculator on all three of these, I hope. I might even do that today. Okay. So this actually vertex, we use an awful lot with other function forms like the circle, exponential functions, because it's so easy to use. In fact, we end up changing many of these other forms to vertex form. And you guys will learn that. So that we can use a vertex form. And then we have the intercept form or factored form. This is really important if you're going on in mathematics. In fact, we're revising next week's worth because we want to include more mathematical concepts used in pre-calc, more stuff like this, where if you're going to go on in math, you need to know. All right, so the first thing here is standard form. So let's take a look at your practice worksheet. Okay. Oh, actually, this is vertex form. Okay, 1 and 2 are vertex form. Again, it's the easiest because it's easy to read our vertex right off of the equation. Remember, it's a times x minus h squared plus k, where our vertex is hk. Remember, our h is the opposite sign that's there, and the k is the same sign. So in this particular problem, my vertex is my h, which is opposite sign that's there, so it's a positive 2. And my k is the same sign, so it's a positive 1. Okay. They want to know the axis. So there's my vertex. They want to know the axis of symmetry. Well, it's always x equals the x value of my vertex, x equal 2. So we can draw that. X equals 2 is a vertical line. It's always a vertical line when x equals a number at x equal 2. So there's my axis of symmetry. My vertex is 2, 1. 2, 1. There's my vertex. And basically, you're supposed to get 2 other points to draw your vertex, but I'm claiming, here's my vertex, 2, 1. I'm claiming you only need 1 because for 2 reasons. If we get this one and figure out what y is, we're certainly going to know what y is when we get this one, because they're the same. Secondly, I could always use my axis of symmetry. Once I get this one, I plot it, and then I can easily plot the other point off of my axis. Okay, so I really only need to do one of these. And I'm going to do 1, because I think it'll be easier than 3. Although I may or may not. Okay. So I'm going to plug in 1 for x. Let's see, y equals 1/2 my x, because I need a value for y here. So that's why I'm plugging x in. 1 minus, actually, the 3 will work better, wouldn't it? Would make it positive. I'm going to use a 3. So 3 minus 2 squared plus 1. So I have 1/2. 3 minus 2 is 1. 1 squared is 1 plus 1. 1 times 1/2 is 1/2 plus 1 is 1.5, or 3/2, however you want to do it, or 1.5, doesn't matter. So I got 3/2. 3/2 for my y, 3/2 for my y. Okay, I'm going to go ahead and plot one of these. So 1 comma 1.5. So 1 comma 1.5. How nice of them to put 1/2 on my y scale. Okay, I know the other one's 3 and 3.5, or 2 units away from the axis of symmetry. 2 units. There's my 3 and 3/2. So here's my parabola. Boom. Boom. Vertex form. Pretty cool, huh? Easy. Easy peasy vertex form. Oh, it also says we got to do domain and range. Domain is easy because the domain for parabolas in this class is going to be what? What do you think? It's going to be like the absolute value, negative infinity to positive infinity. Now, it's not true for all parabolas, but for this class, all our parabolas in this class are either going to go up or it's going to go down. Okay? So the range is always going to be that for parabolas, for the parabola function in this class. Now, the range is different. Okay? The range is going to be our k. Okay? So our k is 1. Our k is 1. Did I screw this up? I put it at 1/2. This should be up here. Yeah, this vertex, I thought that was 1, should be here. I did screw this up. That's okay. I think you guys realize that. Okay, so it should be our k, which is 1. And since this is going up, it's going to be positive infinity. If it was reflected or flipped, it would be negative infinity, and I would have to put that first, and then the 1 here. But since our 1 is the lowest number, I have to put that first because it's the least, and it includes 1, and it's going out to positive infinity. So again, our range is going to be k. Let me just kind of note the range is going to be either negative infinity, or it doesn't necessarily have to be, well, yeah, it does. Okay, it's going to be negative infinity, k includes, or it's going to be k include, or positive infinity. It's going to be one of those two. So there's a lot going on with graphing, an awful lot. Should we do one with a calculator? Should I just do all your practice problems? No, I don't think so. But I will do this one with a calculator, just to show you that you can. Okay, so let's see. First of all, my domain, I'm going to do my domain and range. Domain, negative infinity, positive infinity. Range, since it has a negative sign for my A, I know that it's going to be this situation. Negative infinity, K. Negative infinity, and my K here is same sign, -1. Okay, which tells me my vertex is going to be 3, -1. Opposite sign, same sign. So, I mean, that's why I say it's almost easier to do this without a calculator. But we'll go ahead and try it. All right, negative x minus 3 squared minus 1. Going to graph it. Going to go to my chart of numbers. So I'm going to hit second, graph, and I'm going to try and find my vertex. And I'm looking at the y values when they start to repeat. And there they are. Okay, -2, -2, -5, -5. So this has to be my vertex. 3, -1. Okay, so 3, where's the x? There it is. 1, 2, 3, -1. Do it right this time. I know it's going to open down. Besides, I got a picture of it. And I could just use the points right off here. 2, -2. So 2, -2, and 4, -2. Axis of symmetry is my x equal 3. Well, here's 3. Here's my axis of symmetry. Okay. I'm done. All right, standard form. Any questions so far, guys? Okay, standard form. I have -2x squared plus 16x minus 36. If I follow this here chart, the first thing I have to do in standard form is find our vertex using x equals -b over 2a. Now, this is a lot of algebra here in steps 1 and 2 of standard form. There's no way around it. Okay, so what I'd like to do here is I like to label my a. My a is the coefficient of x squared, which is -2. My b is the coefficient of x, which is 16. And my c is the constant, which is -36. Okay, so my x, let me use a different color. My x equals -b over 2a. This is the x coordinate of the vertex, which equals -16 over 2 times my a, which is -2. So I have -16 over -4, which equals a +4. So my vertex here, where the x value is +4. Now here's a pain in the butt. Now that I have the x value, I got to go back. Step 2 says I got to go back and substitute 4 in for my x. I have negative 2x squared plus 16x minus 36. And my x was 4. Okay, watch your PEMDAS. Exponents first. 4 squared is 16 times negative 2, negative 32. 16 times 4 is 64, minus 36. It's pretty early in the morning, and I haven't had all my coffee, so I'm going to use a calculator. Because I know I'd probably screw this up. Negative 32 plus 64 minus 36. Negative 4. Okay, so my y equals negative 4. So my vertex, let's see, 4, negative 4. I know it opens down because my a is negative. So then I got to pick some points. Okay, x, y. This one's, I'll agree, this is not an easy form to do this with, graphing a quadratic function. This one would probably be easier to use a calculator. But anyway, all right. We need to choose 3, or any number really that's less than 4. If you choose 2, make sure you choose 2 higher for the y. So if I chose 2, I would have to use 6. But I'm going to use 1 low. So 3, 4, and 5. Now I'm just going to glance real quick because whatever one I use, I'm going to use this and substitute in that x. I think I'll use the 3. So I have y. I'm going to use this again and substitute in 3. So I got negative 2, 3 squared plus 16, 3, and then minus 36. Okay, 3 squared is 9. 9 times negative 2 is negative 18. 16 times 3 is 48. Minus 36. And let's see if I have enough coffee for this. Let's see, negative 18 plus 48 is 30. Minus 36 is negative 6. So I got negative 6, negative 6. There's my 3 points. 3, negative 6, and 5, negative 6. Here's my parabola. Axis of symmetry is x equal 4. There we go. Did it manually. Standard form. And intercept form is just as bad with having all these extra steps as standard form. So let's try this calculator wise. So I'm going to go and put this in my y equals button, number 4. And I've got x squared, the x squared plus 2x plus 5. I'm going to graph it. I'm going to go to my chart. Come on. And I'm going to look for my vertex. Hopefully, it's not some obscure number, and I can find, oh, I can. Okay, so I got a 5 here and a 5 here. Not always does this happen, but so far we've been lucky. Remember, otherwise I'd have to second trace and look for that min max, okay? So my vertex is -1, 4, because my y values start repeating after that. So -1, 4, and I'm going to use -2, 5, -2, 5, axis of symmetry here as x equal -1. And I could just, this is one unit from that, so there's one here. Boom, boom, there's my graph. Domain and range is easy. I forgot to do domain and range on the other one. Domain's always going to be -infinity, +infinity for this class. Range, you see I have, it's a positive because it's opening up. So my largest number is going to be infinity, which is my k is 4, bracket. There we go. So, calculator, very, very much easier than manually with standard form. And that's also going to be the case with intercept form, which I'm assuming is on the back. Number 5. Okay. Let's see. Intercept form. Now, we don't use this because I don't teach pre-calc or calc. I hardly ever use intercept form, okay, to graph. So there's a lot of times I have to go back and look at this note page to figure out what to do next or what the formula is. Okay, especially this one. I am so used to using this one, I never use this one. Okay. So we have to find the vertex. Oh, no, in intercept form first. We're going to find our 2 points, our x-intercept first. Okay, so that's the first step. So it's going to cross my x-axis. Remember, you're setting each one of these equal to 0. Right? Remember? So x is going to equal -5, and x is going to equal -3. That's where they cross. My x-axis, -3, -5. I know it opens up because my a is 1, it's positive, so it's going to go, it's going to go this way. Okay, vertex. Now let's do the vertex. Now this is the hard part. Okay, my vertex, again, my x value is going to equal p plus q divided by 2. Oh, in vertex form, intercept form, this is my p, this is my q, right? Okay, so my p, and again, it has to be, I'm going to write the form up here. Y equals a times x minus p x minus q. Okay, it has to fit this form. So since I have plus sign here, my p has to be the opposite, it has to be -5. And we have it right here. There's my p, there's my q. So my p is -5. My q is -3. I have to divide that by 2. I have -8 divided by 2. So my x value for the vertex, -4. Now I have to find my y value. So we got to plug that in for x up here. Again, a lot of work. So I have my x plus Oh, I'm sorry, not my x. My p, my x we know is -4. Sorry. Plus 5 times my x, which is -4, plus 3. So these got to be multiplied together. So -4 plus 5 is +1 times -4 plus 3 is -1. So my y is going to equal -1. There's my vertex. -4, -1. Also my line of symmetry here. And there's my parabola. Oh, okay. Axis of symmetry was x equal -4. Now, if you don't put axis of symmetry somewhere on your sheet, I like putting it actually right on the graph. If you don't do this, you're going to have to put it off to the side here that the axis is x equals symmetry. Otherwise, get point taken off. And what else? Domain and range. Domain is easy. This class for parabolas, -infinity, +infinity. Range, let's see, it opens up, so it's going to be a +infinity. And my k is -1, includes it. Okay. Calculator. Probably going to be a lot easier. Negative. Put your fractions in parentheses. X plus 3 times x plus 1. Hit enter. Or graph. Just hit graph. You're good. All right. Let's see. We can get our P and Q, our vertex. Let's see. That'd be pretty easy. It's going to be -3, -1. Let's just double check. Go to our chart. And here we go. -3, -1. Huh. Not on here. Let's make sure I typed it in. It's saying that our vertex is -3, 0. No, it's not. It's not showing our vertex. Oh, there's a 0. There's a 0. Saying our vertex is -2.5. That don't make sense. X plus 3. Make sure I typed it all in. -1/2. I'm going to go to my graph. It's a maximum for my vertex, so I'm going to go ahead and calculate that maximum. Hit enter. I'm going to get left of the vertex, or the left bound, right of the vertex. Oops, didn't hit it. Enter. Right of the vertex. Enter. Enter. And it's telling me the same thing. The vertex is -2.5. So something's going on in this, that our vertex is just not the opposite of these. So we're going to have to be careful when we have a fractional a. Okay. So it's -2.5. I'm going to go back to my my graph and get my zeros. Oh, duh. These are my zeros. Okay, so my zeros are x equal -3 and -1. Now that makes sense. There's my 3 points. crosses my x. See, I told you I'm not even used to this. My x equals -3, and my x equals -1. There's my x-intercepts. My vertex, -2, 1/2. I know it opens down. Axis of symmetry, x equal -2. Let's see, what else do we need? Domain. Domain, -infinity, +infinity. Range. Since this is going down, I'm going to have a -infinity first. And my k is 1/2 included. Anything else? Nope. That's it. So, like I said, even because I don't even use this all that often, I got confused here, but I got it straightened out. Obviously, calculator's easier. Okay, any questions, guys? Try to, I'll put this on Google Classroom, but try to do these problems by yourself and kind of put the answer key away just to make sure you do it. You can do it. And then you've got the Delta Math practice to do today. Do you have anything else? Just kind of. No. Oh, wait, I take that back. You start the quadratic modeling today. So if you got to get this down before you do the quadratic modeling. If you get this down, this graphing of quadratic functions, the quadratic modeling is just taking this and making it into a little bit of a word problem. It'll be a piece of cake if you got this down. Okay.